Okay, I think you can hear me now.
Test. Okay.
Looks good. And what do we do next? I should probably open up chat, huh? Anyways, hope you're doing okay today. It is Tuesday, and I'm hoping to stream on Tuesdays more. Okay, so there's chat. All right. Okay, so yeah, I guess I just want to turn on the computer and stream a little. Been working all day, obviously, but I think I'm okay. I feel all right. Working on some extra stuff. Yeah. Okay, let's continue. Let's continue our project that I had been working on in the past few streams, I guess. But I have worked on it offline. Hey Gilad, I've been working on it offline for a bit. Yeah. And I don't know, like if you paid attention to the last few streams, you'll notice there are a lot more files over here. I guess one thing I should do is show you the setup that really works here. Let me add a window capture, window capture, and we're gonna add PowerShell. Yeah. Okay, that's a very big window. Also, is that really the window I want? Um, Maybe it's wait, it is. Why is it not showing anything? That's my question. Huh. So there's chat. There's a another window, but not the one I want. What is winstore.exe? Path file library. Yes, exactly. Trying to show this window, but it just shows up as a gray blob. What the heck is? Capture method. Windows graphic. Oh, Windows graphic capture. Somehow it's not the default, but this apparently works. Okay. So today we're gonna be looking at two computers at once, I guess. So we'll just leave it here, and I hope I can remember that it's there. Yeah. So whoa, yeah. Why do I do this? I don't need to do this. Actually, sorry for all that. That seems unnecessary. Because I have a better setup. Okay, so I've been recently working on this library that I needed to work on Windows. So one thing I can do is just SSH into there. Oh. Oh. Third time is a charm. Okay. So we can go to, actually first let me go to, yeah, that's fine. All right, so this is the Windows. As you can see, this is a Windows shell, but I can run stuff in here, and I'm just gonna run a few setup stuff. Shell, yep, and then make, yep, Swift on Windows, dance game. Yeah, differences are messy. Yeah, so what's interesting is like I've been looking at Python code, Rust code, um, And Foundation, to be honest, Foundation recently, the open source version added a lot of Windows support, and it's being super helpful. Yeah, so that's I've been looking at all the alternatives and hoping to. Yeah. Anyways, I think it'd be beneficial if we kind of walk over what have changed. I don't know where I left off in the stream, but we can just go over some overview. So this is file system library, and the main actors, I guess, is I guess it's a thing called path, and then if you just go over path, you'll notice some properties and some initializers. And whatnot. But there's also all these pure path thingy, which are okay. So interestingly, path is supposed to be public, but not all of this is supposed to be public. So for example, this pure property that changes type according to OS is not public, right? And then we can go to this pure Windows path, which is actually public. Jump to definition is not working. Let's try fix it. Okay, whatever. Windows, pure Windows path, and pure POSIX path. So the interesting thing about this is they are available regardless of OS. So you can go to Windows and make a POSIX path if you want, because they are pure. So that doesn't pure meaning they don't require system API to operate, and it's really convenient in terms of, for some reason you want to write a program that does manipulates the format path in the other platform. So you can use these. These are public, and so the difference between them, obviously, we all know the difference between like the // having a drive or not, having this UNC. I guess UNC is not very commonly known, but anyways, there's like the superficial differences between OSs. But the really interesting part is this encoding unit thing. Encoding unit. So on POSIX, everything is in bytes, 8-bit units, and modern OSs usually just encode their paths in UTF-8. And on Windows, the default is UTF-16 lower Indian, small Indian, lower Indian. So that's why, and also the Windows API actually gave you things in 16-bit integers as opposed to 8-bit integers. So I actually rearranged how this should be implemented quite a bit, and this is where I'm at right now. We have these type aliases that kind of paste over the fact that there's platform differences. So if you really, when you use path, for example, you do have this binary string property, but it's just binary string. But if you actually look underneath, beyond the signature, the textual signature, you'll notice that it's actually on Windows, for example, it would be Windows binary string, a binary string. A Windows binary string is really just a contiguous array of the native encoding units. So so I have this interesting problem of I have the pure path, and then the path actually is a superset of pure path. So in this case, the most natural and easy way to kind of forward that interface is obviously inheritance. But I also want value semantics for this path. So I chose to use just manual forwarding. So so far, there's nothing specific about the path itself. So everything it has is forwarding from the pure property, which is the pure path. But when it comes to platform dependent operations, I'll implement it in terms of path, and then all of those will be under compiler flags. So another, I guess, kind of interesting thing is these paths. They actually look super similar. So I struggled quite a bit trying to see if there's ways to how do I put it? Reduce the duplication, but I think my conclusion is like interface level duplication is acceptable because like I thought of ways of using generics, using protocol, using type erasers, um, using like manual witnesses. I guess it's also using structs, like all kinds of arrangement. But I think the real concern I had is performance. It's like I imagine people using this library, calling these functions, making these structures in the most innermost loop of their program. So I want it to be cost as little performance as possible. So this is also why the paths are not stored as string, and they're stored in this binary format, because this is what the system APIs gives you when you ask for example, a glob. The calling the glob function in POSIX, or if you ask Windows to list, they give you like a list of current file names in a given directory. They give you these bytes, right? And then it's up to you to decode them. And obviously we can decode them into Swift strings, but decoding takes time. And a lot of times when you work with paths, you don't really care about its content. What you care about is like you list them out, and then you find the ones that, you know what, this is actually kind of interesting. I think I may change this in the future, but my initial thing is like, if you just take path from somewhere and use it elsewhere, for example, you open a path, or you get you give the system a path, and then you verify that it exists, and then you write to it, or something like that. Or if you get a bunch of paths somewhere, and then you want to I don't know, move them elsewhere. For that kind of thing, you don't really care about things like, what is the root in the path? What is the drive in the path? What are components of the path? Or how does the path look like to the user? You don't really care. All you care about is, here's a blob of data, I'm going to use it somewhere. So in those scenarios, you shouldn't go through this encoding, decoding exercise. And instead, you should be able to just use it as a blob, as an abstraction. But as I was talking through that just now, I started to realize that most of the time you probably do care about some type of filtering or path manipulation, right? Like, for example, if you recursively find all files in a directory, you may want to, like, say, filter them by a suffix or something. But that might be faster in bytes anyways, in binary formats anyways. Yeah, I'm thinking. Let's take a look at an example. I want to have some example that can so for this project I wrote a lot of scripts. One of them is, for example, generating the CMake file, which we'll use on Windows, right? So here's a whole, like, a big-ish Python script, and it does a whole bunch of path manipulation, right? We get the current directory, and then we change the program's current working directory to a given directory via the command line argument. We do a glob, and then we change it again, and then we join some paths, and then we join more paths, and then we find the relative paths in terms of of a given path in terms of another root, and then we do more globbing, like, and then we do, yeah. So anyways, I didn't intend to use this as a write this file as a illustration, but I happen to, Python is available everywhere. So it's very handy that I can update the CMake list with this little script. But it demonstrates like what makes Python great when it comes to scripting, right? You just like all the file system manipulation is so fluid. You just like throw them all together and do your thing. And this is super powerful. And this is what I want my user to experience, right? So let's see, where in these do we need things to be not binary? I think only this part, right? Only this part. So when it comes to relative path, is a matter of analyzing common prefixes and things like that. So that you can do with binaries. No problem, right? No problem. Yeah, you can do that with binaries. Yeah, this part, it is join. In our case, we'll take a path, join without the path. That definitely can be done with the binaries. Yeah. Okay, so yeah, even the user can give us string. We'll take strings if it's a string, but it doesn't make a huge difference, I guess. We just convert them into binaries. Yeah. Okay. Why don't we just implement this? Maybe this is the first thing we'll do today. It is an interesting exercise. Okay, let's implement join. Do I still have the protocol? Okay, so I have a protocol that I make everything conform to only with debug builds. So this doesn't exist in release build, and it keeps me honest in terms of everything needs to implement the same interface, right? So let's do that. Let's add a method to everything that's called join, right? And it will join so there are a couple of ways to do this. No, actually there isn't a lot of ways to do this. So my goal is like, if you want to join a bunch of mixed types, like if you want to join binary and your string literal, you should be able to do that, right? So what are we taking in this join method, right? So join with others, and then there's a type here, and then we can make it Variadic. Okay, so what is this type? This is the interesting part. So obviously it has to be either a string or a binary string, right? A binary string, however, is unconstrained associated type. So we need to constrain it. We need to constrain this to, okay, so in practice, we have 3 things to deal with. Oh, maybe this can be as simple as a tag type. Let me think. The difficulty here is binary string is a type alias for contiguous array, and I want to tag contiguous array is this possible? Let's think. So let's make a protocol, right? Protocol pass string path string representable, something like that, right? It's just a tag. It doesn't have any requirement. Well, would it? Does it need any requirements? Yeah, I probably need some requirements. But for now, we'll just leave it empty, okay? And we can easily make, if it's empty, then string can get a free conformance to it. String like this. Now, I can't simply just make a contiguous array conform to it. Well, I can, I think, but can I make it conditional? Extension contiguous array. No, I have a distinct feeling this won't work because you cannot make it where element is U16. Let's say this. Can this work? Okay. Yes, now we have a conflicting conformance. Yeah, this won't work. That's really unfortunate. And actually, this has prevented me from doing a bunch of abstractions already. And this is just a restriction of the Swift language at this point. So I can either choose to work around this or tackle this now, right? We just fix it. We can fix it by making these binary strings concrete types that wraps a contiguous array. And then we lose a lot of nice interface from the array itself. So that's gonna blow up a bit in terms of implementation. But I'm not too concerned about performance or anything like that. It's really interesting because this wouldn't be a problem if we choose to say make Windows binary strings and Windows pure Windows path not available on POSIX systems. This is just like not a problem at all. Because essentially you just have two libraries. One is compiled for Windows and one is compiled for the rest. And then you just share code whenever you can. And then the two libraries doesn't know about each other. Oh, what about this? Hmm. So string is a collection. Contiguous array is also a collection. Right? I think the right approach here is implement this for implement this first, and then we can see what are the requirements that falls out of it. So let's go to POSIX path and then implement it. I'm going to pretend that I take string, right? Which is not a big deal because it can easily convert. I can easily convert. Oh, this interface is wrong. This should return a self. Okay, and then let's go here. Okay, let's return a self. So I can turn yeah, so this is the funny thing is I already implemented converting string to paths, right? So I can do like others, map. This is trivial and also very efficient actually. Okay, so this is the first requirement for our string is just placeholder. But for whatever is going to replace string, must be able to convert to the native type of path. And then we just have another function that implements this. So So we can have a pure POSIX path convertible or something like that. And then it doesn't have to be pure, I guess. POSIX path convertible. And then it requires POSIX path or as POSIX path, something like that. Pure POSIX path.
Okay, and then pure POSIX fags is easiest implementation for this. Extension pure POSIX path. POSIX path convertible. This just returns itself. Oops. Super easy. And as we've established, string is super easy as well. Convertible. Yeah, you're right. It's an I. It's not convertible. It's on convertible. Thanks for pointing that out. Pure POSIX path. Self. Okay, so these all use of undeclared type. Oh, because I fixed 2 places instead of 3. Okay, so now these guys are convertible. Now we can do public. Well, the interesting thing is it's easier to not do it here. Put this here. Can I use this as existential? I think so, right? Does it have self-requirement? Probably doesn't, right? Let's just return, return self here for now. To do. And then, does this compile? I think it should compile. Yeah. Okay, so we can go ahead and implement it this way. And then we need to make it so that if OS is not Windows, when this happens, we also make extension string, path, POSIX path convertible, var path, as, so this is simply self.pure. Believe this can work, right? This should work. So this is super interesting, Convertible. Convertible, representable. Yeah, convertible is fine. Is as a good convention? Good enough. Okay. So let's throw this in a file. Add POSIX path convertible. So unlike the previous iteration of this library, I am not, at least for now, not very conservative when it comes to adding interfaces. But I think we should, do whatever is necessary to get over things. And then we'll look at how to reduce the surface, API surface. Okay, so this should work. Yep. And then we have a very similar thing. We'll just save it as sources, pathos, Windows pass convertible. Okay, and then let's open that file. Not this file, this file. And then we just swap out the word POSIX with Windows. And then we can invert this condition. Okay. Now what? Now, binary string. What if I add a new associate type called pass convertible? Okay. And then I can add this interface maybe. And then I need to update all three of this such that this works, right? So let's try make this happen. Pure path. I already have one. Apparently this doesn't work. I'm gonna remove this two requirement. Oh, those two requirement, and try to make this work. Maybe it already works. Yeah. Okay, so that's not too bad. You just make this existential associated type. Okay. All right, so let's do the same for Windows pure path. Pure Windows path. I need to learn to say that correctly. Windows path convertible. Yep. So I can uncomment this. Hope. Okay. And last but not least, this guy is using this binary string thing. Binary string, if I recall, is a type alias. Yeah. So we can do this. If it's Windows or type alias, pass convertible to be Windows pass convertible. Why was there two separate suggestions for this? If it's POSIX, we'll do very similar thing. Just remove the evil word and replace it with a good one. Okay. This should be okay. Yeah, so because inside the protocol, the associated type overrides whatever symbol exists in its environment. So I'm not too concerned about that. Now comes to, let's come to here. And interesting how all this have doc strings. Okay, so just go to this guy, copy paste, and then self to do. What's interesting is both the type alias and the associate type is spelled the same, so this should just work, right? I haven't commented out the type, the protocol conformance here. So just this at least should compile by the merits of the type alias. Yes. Now, I can go back here finally and uncomment this. I don't expect anything to not work here. I need to make that public. Yeah. I think things are okay. Oops. Things are not okay. Because path convertible needs to be public. Which means all the other two needs to be public. Okay, so this needs to be public, which means Windows path convertible needs to be public. Not a big deal. Oops, I typed Windows. And that won't work because we're working with POSIX here, so we need to make the other one public. So from a user perspective, as long as you look into this, right, it's fine. String is public. String is a currency type. Pure Windows path is public. Path is public, so all of this can be public. This is what I talk about what I mean when I said the blowing up the public interface. It's quite a bit of bloat here. Oh, in protocol, you don't need to say public. Okay, looking good. All right, so I guess we can check some of this in. Boop. Let's see. So we have these convertible files. Path has a to-do in there. Pure, the to-do. This I can't check this in because things won't build. So I guess it's just this new stuff. I wish the conformance is private. Yeah, if I use type erasure, things will be the API surface will be smaller. So this is something I need to seriously consider in the future. Okay, good. Okay, let's check this in. Oh, this is an interesting thing is like when I commit, I added a pre-commit hook. So it's gonna run Swift format now. And for the first time, it's gonna build it. So it's gonna take a little bit. Please? Okay. And add protocol for convert. Add existential for path. Yeah, it's good enough. Okay, so I guess we can start implementing those join methods. Let's go to our favorite path, the pure POSIX path, and implement it here, right? So naively, if you're given a bunch of paths, all you need to do is, connect them with a /, right? But the tricky part is there's a behavior where user could ask you to join a bunch of absolute paths. So let's observe what Python does. Okay, actually, all right. So I have P1 being path. You know what? I like OS paths better. So let's just use that. From OS import path, and then path.join, right? This is so much lighter. A, B, C, and D, right? This is super intuitive what needs to happen. And we can also say D/E, super easy, super intuitive. You can have repetitive names. That's, we just join them regardless. Doesn't matter. But what happens if you ask A, B, C to join with absolute path C, right? So now suddenly C replaces it. Okay. And this happens regardless of how many paths you have before, right? So this is interesting. And on Windows, let's try one of those. Pathlib dot Windows path. C, I don't know, raw C A B. Whoops. Cannot instantiate, blah, blah, blah. Yep. Runtime error. See, this is an interesting thing. Like, with my library, you don't even have Windows path. So it's a compile time error if you try to do it. Oh, pure Windows path. Pure Windows path is possible. Okay. So if we look at the inside of this path, p1.parts, let's say. So it has a so-called anchor, right? Anchor is the combination of drive, plus root, right? This is one backslash, but Python quotes it, so it looks like two backslashes. Right, so you can join P1, I believe, join path, okay. So if I say something like C, yeah, it behaves very similarly. What if I say P1 join with D drive C? Okay, so this is the interesting part, right? When it is an absolute path, and on Windows there's essentially two roots. The backslash being the first root, and then the drive itself is the second root. So if you just override, you can override one root without the other, and you can override the other root as well. What if, let's say, I want to join with E drive, not absolute. I don't know. I don't even know if this means anything. Apparently it does. Join paths dot anchor root drive. Okay. So for some reason, I have a misconception on Windows that if you have a drive, then it must be absolute path. But in this case, is it absolute? Is absolute? It's false. Okay, so it's purely dependent on the root. You can have a drive and not absolute. This makes sense, right? This makes total sense because yes, you can have same paths on different drives, but they're still relative paths, right? Okay, okay. I never. It's interesting. I never learned. I never perceived it like this. I guess I learned the concept of absolute and relative paths on POSIX systems. That's why, even though I used Windows as when I was little, I never really mapped these concepts back. Okay. Okay, so that's an interesting exploration. I think we all learned a lot, but I think I'm just gonna go and copy Python's implementation. Wait, before I copy Python's implementation, I can copy my own implementation. I implement this, right? Hold on. Yeah, we're working on the same project on a different branch. So just look at the web version. Okay. So here's Pathos. We're looking at master. We should really rename it to main, but whatever. Then there's a join method. It's probably not here. It's gonna be in path analysis if I know myself enough. Join. Yeah, join paths. Okay. So let's see how is this implemented. First of all, it doesn't have docstring. So we have a bunch of other paths, and then it's like, that's super easy. Super easy. Yeah. So literally, we have a variable, and then if we go down the list, we see an absolute path, we just start over, right? Otherwise, we append it. Yeah, but the first time we just straight up append it. The second time we stick a separator in there, and then we append it. That makes a lot of sense. Actually, I think our analysis just now is super useful because I think the reason I quote unquote intuited that is because I've written this before, right? Even though it doesn't include the Windows part. Okay. So another interesting problem here is, yes, that algorithm pieced together, let's say, a buffer that has the right content in it, right? But maybe that's good enough for now. My concern here is I have a lazy. I don't want to go into it too much, but basically these drive, root, and segments thingies are lazy, so you don't have them by default. And once you access one of them, they get computed lazily. And then you can use this parse method to advance that computation if it really matters to you. So you have more deterministic performance. But this awkward part is like I'm piecing together all this information. Yeah, it's fine. I'm overthinking this. Join method shouldn't trigger that computation. Yeah, overthinking. Join with others or paths, I guess. So my experience tells me whenever you use a variadic parameter, you need to also provide a array version. This is because Windows Swift is really awkward when it comes to forwarding. So for some reason you need to use others. Wait, let me think. No. Yeah, let's say if you have an array of things and you want to call this method, you cannot call the variadic version. So that's the awkward part. Okay, let's just write the documentation here. Join with other paths. Absolute path will override existing path being joined. Existing value. Let's just be vague for now. Let's write some example, right? Example. For example, path A and B join with or joined with? Joined with. Joined with? Joined with. Joined with is more grammatically correct. Yeah, whatever. Joined with. String is a path convertible, so we can use string here. So let's start with this. This yields path A, B, C. Then let's do the other version with the forward slash. Then now this time it just gets C. Okay. And then let's document the parameter. Parameter others, other paths, other values that represents path. Okay. Returns result of joining paths. So this also should be available as a operator. Yeah, probably will implement plus. That's I guess this is a good goal for this stream is like implement all of this stuff. Okay. So update this. Return the wrong value for now. Then there's the other version. Oops. I'm starting to think this Windows guy can go away for now, right? Haven't used it for a while. Path convertible. In this case, it's going to be POSIX path convertible. POSIX. POSIX path convertible. Okay. And then we can paste this to Windows. And POSIX to Windows. Come on. Okay. Path. Oh, wait. Did I forget? Oh, I didn't forget. Okay. I was like, did I add the ed after join? Okay. Let's do this. This time is agnostic. All right. So next question: how do I avoid implementing it 6 times? Right. So the easy version is obviously the first call. The first method can just call the second one. So let's just do that. That's super easy, super nice, free. Joined with. Just look at that. Does read so well. Self joined with others. Oh, I really like the Swift API design guidelines. It's just make programming so easy. Okay, so that's the easy part. This is also the code duplication I mentioned earlier. It's like, look at me, I already wrote the same code 3 times, right? Okay, so now next. Oh, right, for path. All I really need is self.pure joined with others as usual, because yeah. So now I just need to worry about 2 versions of implementation. 2 versions of implementation. Each is concerned with a path convertible of its own platform. But this code really shouldn't have 2 versions, right? At the end of the day, we're talking about contiguous array here. So we can implement here probably. So here we have contiguous array whose element is integer. What if I implement it here, right? I have a function joined with others, join path. Or path join with others. Self, right? And then we can just go to that implementation where we have a buffer of element, I guess. Right, and then obviously we have self, so we'll just go over wait, that other implementation has some weird stuff in it. Where is it? Why does it work this way? Oh, because it's a free function. That makes sense. So I should have a non-free function version of this, like a method version of this. Join. Oh, it just takes. Haha. Yeah. That makes sense. Okay. Okay, so I think the easiest thing to do is just make result to be self first, and then we'll just go over others, right? Other in paths, right? And then if other has prefix, not have, has prefix is wrong. Because now there's the Windows bit, right? So maybe this is too low level because we need to understand the concept of a drive. Maybe it is worth to have two separate implementations. I'm overthinking this because that means on POSIX things will be a little faster. We don't need to worry about having a drive. Yeah. Okay, let's just do one version and then think about the other one. So we have all paths. All paths is self plus others as POSIX path. POSIX path, right? Oh wait, others map. $0. Okay. All right, so now we'll have a list of POSIX paths. Right? I can annotate this, but yeah, no, as POSIX paths ensures that. So now we have a list of pure POSIX paths, which is just contiguous arrays, and then we can start, right? We can start result. We're gonna do array first. Result is POSIX encoding unit. And then for in others, I don't like the word others. There should be paths. Yeah, paths make more sense in the documentation. So fix that. Then we'll fix the rest as we go along. Self joined with paths. Other paths. It's fine. This is just for myself. Yeah. Okay. Now, for other in paths. Now this is identical algorithm. Finally. If other has prefix I think it was, I don't know why I'm not having autocomplete today. What? Oh, whoa, 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 whoa. This is so wrong. Okay. That is so dumb. Okay. Let's fix it. Ah, this is good. I don't know why it was wrong over there, but okay. So pure join with others. Oh, right. That makes sense. Okay. So before we do this, we also have to construct a path. Probably means we need to add a new constructor. Oh, no. Oh man, do this needs to be in here? I feel like this is aliased somewhere, right? Pure path? It's gotta be aliased. Yeah. Path is all about aliasing, taking advantage of. So I can just say pure path. Like this. And I'm going to create a path from pure path. Okay. Also, some of this documentation is just wrong. Okay. Now this should work, right? Because pure join with others gives you another pure. Oh, yes, except the signature is wrong. Everything else should be okay. All right. Let me just inspect the Windows one real quick as well. Looks like we've got some copy paste error here. Why isn't SourceKit happy today? Okay. I guess back to business. Yeah. So we have a array of units, right? And then we can say like, for if other, oh, I don't call it other, just call it path, right? Let me try one more thing in Python. Port. So path join A, B, C, D. Okay, A, B, C, D. Right, so the separator, yeah, that's one thing that this does right, is like it doesn't create, it has an extra separator if it's already at the end. Okay, that makes sense. All right, let's do this. So if path has a prefix, or rather paths. See, now it has autocomplete. Path dot first. Does this work? Wait, what's in a pure path? I need to do path dot binary string. Right, that means I need to add more initializers for these as well. Okay, let's do that first. This documentation is wrong as well. Okay. Create a string from a binary string. Okay. Then let's go backwards and look at this first. So we need to update it, right? Oh, pure pass. Right. Okay. Yeah, we cannot convert that yet, but we'll fix it. So now I can go to pure POSIX path. Just take this, I guess. POSIX binary string. It's literally just self dot binary string equals binary. I don't even need this. And then before I go back to implementing the method, we'll add it again. So this replication is getting to me a little bit, but I also am very aware that it's very much a implementer's pain. Users will get a relatively good experience out of using this. The bad experience being like if you just go through the list of public interfaces, you'll get overwhelmed a little bit. So like I'm planning to do some clever stuff, or maybe not clever, but like heavy work into the documentation so they don't look too daunting. Like if you just auto-generate documentation for every public method, one, you have to duplicate a bunch of documentations because they're functionally the same in other places. So two is like just like seem like a lot of stuff. Okay, immutable path and reviews. Okay, so now we can go back here because we have a path which is the native pure path format. Now we can take the binary string out of the path and say if it has a prefix. Actually, even better, right? If it starts with, or even its first value is POSIX constants. This is why I wanted autocomplete separator byte. I really should call it something else. It's not a byte on Windows. If this is the case, result will just be array Actually, can I keep it contiguous array instead of converting it back and forth, maybe? Okay. Otherwise, right? If result string is empty, or what's the other condition? What's this branch? I don't want to think about it. I just want to copy. Blah, 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 join. Okay. Result has prefix. Oh, right. So if the result is already absolute path, we simply had suffix. That makes sense. Yeah, if the result string already have a separator at the end, then we simply attach the new path to result. And I'm hoping this is possible with contiguous array. Oh, result string, binary path, binary string. Okay, else result string. Yeah, we need a separator, POSIX constants plus the new path dot binary string. Then finally we return self with our new initializer. Oh, come on. Good thing we can use array literal with a contiguous array. Okay, so this is not bad. This is not bad. The only bad part is the other implementation for Windows is essentially the same. No, it's not the same. What am I saying? Because that other one had to deal with drives and stuff. So let's use our fun stuff. We have format, 6 files skipped, 4 out of 71 files changed. I wonder what it did, but doesn't look like. Oh, removed self here for me. Okay, it doesn't look like anything dramatic changed. And then we have update CMake lists, which is finished immediately, but you can see we got some changes here. Let's take a peek. Blam, now our new files are in here. Great. I guess we can write some tests. POSIX path joining tests. Oh, by the way, I think I want to show off a new logo. When I'm really tired, but I don't want to go to sleep, I doodle. So by doodle, I mean I just trace stuff and sometimes I make stuff. Okay. Blah 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 blah. Import XA test. Final class. What do I call it? POSIX path joining tests. Okay. Let's just try some basic stuff here. Test simple joining. So the simple joining is not what you think. At least not what I would think. Simple joining should be pure POSIX paths A and B. And then we're testing. Oh, these paths should be equatable. Never thought of this. Huh. That's amazing that I didn't think about that until now. There's some code bit rot in the makefile here. Okay, everything is good. Let's add that equatable confirmation here. So pure path representable should also be equatable. Maybe even hashable. Yeah, definitely hashable, right? Because it's very useful to use paths as a key. And now if I go make build, things will fail because we don't actually implement those. So let's go and implement those. I don't know if there's anything other than just declare. Hashable, equatable. Gilad said, I think it's not that bad so far. I'm not sure what he was referring to. When pure Windows. Okay, let's try this, right? Equatable, hashable, hashable. Okay. Type pure Windows does not conform to hashable. Is there something it can't derive for? Oh. Part storage. Looks like we do need to implement it manually. That's fine. So instead of putting it on top, we'll implement separately. Same here. This is even misspelled. Embarrassing. Okay. And we'll go to path and do the same thing. Declare path as equatable and path as a binary string as storage. So it should be easily equatable. And then they also have these two. Oh, it doesn't have binary string. It just have these two, which are both already equatable. So we should be able to synthesize that part. Okay. Now hashable. Extension pure POSIX path hashable. Okay, is not gonna be. So what is the signature? Like hash into or something? Hash into, perfect. Thank you, SourceKit. And then you say hasher dot combine hashable self dot binary string. Must be declared public, no problem. Perfect. Everything else doesn't matter. The parts thingy is derived from this value anyways. It's gonna be a little interesting when we as like metadata. Oh no, but that's not part of pure path. Okay, pure path is simple. Okay, this doesn't even need to change anything. Oh, I guess we do need to change the spelling. Good. So can I just derive this now? Since this guy doesn't have any lazy property. Path representable. Redundant conformance to self-equatable. Ah, yeah. Hashable implies equatable, huh? Why are there so many notes? Oh. Stored property type box optional does not conform. Okay. That makes sense. So let's go to box. Can I just say this is equatable? I mean, that's the lazy way to do it. So this is a box. Inside the box is an optional. Inside the box optional. Oh, it's a path parts. Right, but I don't really care about path parts at all. Okay. So it turns out this lazy property is preventing us from synthesizing equatable. That's a little sad, but that's okay. Equatable. How do you implement equatable? It's like a static function, right? Left hand side, self, right hand side, self, return bool, and then left hand side binary string equals right hand side dot binary string. That's all I care about. And this needs to be public. Now it's equatable. Okay. Whatever. Windows. Okay. And we can take this out. And then I think for path we can still synthesize because the only stored property are these two things that we just worked really hard to implement. Okay, so we're good. Now we can go back to writing tests. Not this test. POSIX path joining tests. Simple joining, XCT assert equal. A joined with B is equal to pure pos path A/B. joined is inaccessible because of internal. Great. I love failed tests because it's like a free stuff. Bum, 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 bum. Free tips. It's like, wonder what you did wrong? Write some tests. Okay, this is wrong, right? Okay. No. Here. All right. So make test again. Aha. 31 tests all passed. Great. Simple joining. There are many variations here. I guess in the simple joining, let's also throw in a C here. A joined with, should this be a separate test? Simple joining with multiple other paths. Let's just C and D this. C, D, C, D. This is still very similar to the first one. B, C, D, A, B, C, D. So this would pass, no problem. Okay. Test simple joining with the existing separator. So essentially it's the same here, except we throw this in. Oh, throw this in there. I guess simple is no longer required. Right, so this would be the same. Okay, that's another case. What else? Test simple joining starting with absolute path. A join with B should be, wait, why are there two of these? Huh. Okay. Starting with absolute paths. Wait, I guess we can test ending with absolute path. Starting and ending. Just, throwing all the combination here, create a simple test for each scenario. Obviously this is not going to continue forever, but we'll do our best to mix things up. So this simple joining with absolute, with multiple. Well, let's just not end with it, but we're throwing another one here. Actually, let's do B. Yeah, B, B, C, and then D, C, D, B, C, D, and we should expect C, D. Okay, it's a lot of tests. We went from 31 to what, 37, 38? Oh, we have a failed test. Can we eyeball this? A, B, C, D. This one looks okay. Ah, this is wrong. Eyeballed. Okay, 37 tests. Yeah. Test joining mixed types. We'll keep it simple though. Let's just do this. Oh, why do I have this here? So A, B, C, D as usual, but B this time is a string, and D this time is a string. And it should just work. This one is like if it compiles, it works. Nice. We're almost there. We're almost there. We just need to repeat all of this for Windows, which is slightly more interesting because of the drive, which is also a little dreadful, to be honest. I have no idea. Let me think. So, yeah, for the other one, I mainly just stealed from my past self, right? So let's think about this but throwing in a drive. So if the other path has a drive, oh, what about UNC paths? God damn it, this is so complex. Okay. From path lib import pure Windows path. Come on. Pure Windows path. Okay. I don't know. PW equals pure Windows path. Okay, so P1 is PW C. Oh, let's just root. Okay. Right. We need to make this a raw string. Come on. Python stop. Okay. P1.drive is C. P1.root backslash. Okay. So P1 is simple. Let's do P2. P2 is C A B. Okay. P2 parts anchor. Okay. And then P3 is a UNC path. So we want PW. Does raw string just not work now? Like, why do I need to quote this? So let's not do that. How does PNC work? Like UNC blah blah AB, I think. Oh, no. forgot to quote everything. And we're supposed to start with 2 backslashes. Yeah, so the anchor here is this parts, and then the drive should be that part without the last backslash, and then the root. Okay, I get it. So a UNC drive is just a drive. Yeah, that makes sense. Wait, do I have a test for that? Sorry for going on tangents, but parts parsing drive. Do I have drive tests at all? Parsing drive on Windows 2. Let's do parsing oops. UNC drive. Cuz that's a hard one. Right? So we do 2 backslashes drive name AB, and then our drive in this case should be this part. Did I implement this correctly? I don't recall. I doubt it. Wait. Yeah, there's no way I implemented this correctly. I did. What? Let me just make sure. The way to make sure of this is just run that test. Swift test filter this. Run that test. 1 test, 0 failures. Okay, it works. I'm a genius. Okay. So the reality is, like, I keep forgetting the complexity, and then when I recall it, I kind of shock myself a little bit. That's the, not that I'm genius. Like, but after that, yes, I do feel like a genius. But also after I do this analysis, I feel dumb again. Okay. Okay, now let's implement that join with the drive in mind. So assuming our drive is implemented correctly, actually, wait, why is this being built every time? Hold on. Oh, wait. There's some aggressive cleaning this make file, isn't it? Yeah, every time I test, I clean everything. That's dumb. Stop that. Wow, it's been an hour and 50 minutes. Past self comes back. Yeah, I think it's because, like, in the past I used to I think there's a reason. I think I used to generate like an Xcode project to support Carthage. That's why when you run test, something is being tested in the code generation part. So in order to run all the tests, you need to delete the generated artifacts and then rebuild it through tests, and then test the result of building that. That's why you need to delete all the artifacts, but now I don't need to do that anymore. So, you know, like, okay. All right. Add a test for UNC drive parsing. didn't remember supporting it, but it works apparently. Okay. Right. Hold on. Too many things. Okay. So assuming that works, let's go back here and think about what is our algorithm, right? We start with the empty path, fine. Well, obviously everything has been converted into a pure Windows path at this point. And then we take the first one and we ask it, oh, this is so complex. See, it's this. It's like this. So we have P2, P1, P2, P3, P1. Let's also make P4. P4 is gonna be PW C D E P4 parts. I said that like a Irish person because I want to say path, and then I ended up saying parts. So P1 also has a little bit of problem. Not P1, P2. Okay, P2 is actually not what I expected to be because I forgot a backslash here. So P2.parts should be CAB. P4.parts is CDE. And then P2 join path P4 should be CDE, right? Same value as, yeah. So here is like drive is the same. Wait, yeah. Okay. So I can just replace the drive. So this is actually a simple case. In the case where drive is different, or actually if the next path has a drive, we just take that drive. We just take the entire path, right? If the next path doesn't have a drive, but it has a root. Where were we? DE, right? We can do FG. P5.parts should be root FG, okay? And then P4 is CDE. So P4 join path P5 should be CFG. P5. Wait. CFG, yeah. Okay, so you have a root, you have a drive, or you'll just take over. But if you don't have a drive, but I have a drive, then I will. Okay, so I need to keep track of drive separately, essentially, right? Unless there's some other way. If other has a drive, we'll just take over the whole thing. Let's assume we just have one buffer to do everything. Otherwise, it means it doesn't have a drive. Then we can think about this case as well. If the result is empty, or what's the best way to think about this? Like, we can enumerate all the possibilities, right? Should I just write the code? Or write the tests? Yeah, write tests seems like a good idea. Let's write tests. So I can just start with Windows joining, POSIX joining test. We'll save it as Windows joining, Windows path joining tests. Then we can open it up. We do the trick where we replace POSIX with Windows. Obviously, it's not going to be complete, but we can start by make some raw strings here. Pure Windows path join with ABCD. Same. I don't know. I can just do some manual stuff. It's okay. So these tests should just pass, because this is a subset of the other one. I mean, the one we're going to write. And this input having / is actually allowed, but we'll just ignore that for now and make everything nice and even. Right, so yeah, that's a path with root. It's another one, quote it. Quote all of these guys. Oops. Okay. Probably can search replace this stuff as well, to be honest. But there's not that much stuff. Oops. Now the question is, how many of these tests will pass? Let's give it a shot. One test failed. The failed test is this one. Blah, 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 blah. Test simple joining with multiple absolute paths. Simple joining with multiple absolute paths. Wait, multiple paths, not absolute paths. Also, there's a typo here. Okay, so we're joining ABCD and Windows path joining test dot. Okay, so contiguous array 97 is not equal to, yeah, of course. Oh, yeah, because I didn't implement it, so it failed. That's good. Perfect. Yeah. That's good. All right. Let's move on to the interesting cases. What should surprise me is all those other ones passed. What the heck? Wait, what the? I'm really confused. Okay, let's use a nice GUI window interface from Xcode. It's a little hard to read with this, so With this, we can click and point. That's slightly nicer. Let me blow this up for you. Okay. Where were we? Windows path joining, right? So you're saying this one passed for somehow? No, it didn't pass, right? Because all we did is return self. Yeah. None of this should pass. Okay, okay, all failing. That's good. That's good. All right, I think maybe we should start running tests here because it's. I don't know why this just claims one failure. Maybe it aborted all the other tests. Or maybe it did complain everything, but for some reason in the summary, it just says one failure instead of n failures. Oh, 8 failures. Maybe I'm just blind. Okay. Okay. All right, let's write the other tests. So what's the interesting ones? Ones with drives, right? So essentially drives should have similar behavior with as absolute. So we can just duplicate this and say simple joining starting with drive. And then what is starting with drive is like C colon, right? C colon AB should become C colon AB. Okay, we need to be really careful doing this because down the line we may confuse ourselves if a test is faulty. Okay, so drive and absolute, I guess it's root. Drive and root. So this is also should be a very simple, very straightforward case. Okay. Now let's go down here, ending with absolute path. Let's do ending with drive. Ending with drive. Okay. We're being botted. This is really annoying. How do I ban all of this? Wait, this guy's not a bot. He says Nim. Are you a fan of Nim? This is not Nim, by the way. Sorry to disappoint. GPU Pro. Welcome to the stream, though. We're writing some Swift. Yeah, I'm a big fan of Nim too. The dude is making a lot of progress, and I'm very envy of him. Like he did so many clever things that in retrospect is so obvious, but that's how good things usually turn out, is like only obvious in retrospect. Like things like bundling in C headers for different platforms, so you can cross compile just with the built-in compiler. That's amazing. Yeah, I have to check out Nims one of these days on my stream. It's gonna be fun. Have I seen latest ArcGC? No. Wow, he's adding reference counting and garbage collecting. That's like a little surprising to me because my understanding is he's trying to create a better C. But I assume like part of fixing C is provide a safer memory model. So yeah, that's pretty cool. Yeah, like his project Nim and Serenity OS are just two projects that I follow and absolutely love. It's like these amazing developers just like going at it, like building amazing. One case is system programming language, the other is operating system. It's like, holy shit. Okay. Ah, yeah, I guess I can do this, right? So we join A with B, which has a. So I assume this should be. I already forgot all my examples, so let's just do it from scratch. So we have A, join path PW, B with this, no root but a drive, and then we look at its parts. So it's C and B. He's borrowing ideas from Rust for determining move semantics statically without needing for borrow checker. Oh, so is arc in this case atomic reference counting? Wait, what is arc in Rust? But arc is a concept in Rust and Swift, but they're different concepts. I think it's atomic reference counting, right? Okay, because in Swift it's automatic reference counting. Automatic reference counting is different. It's basically statically telling you, or adding retain and release for you. Yeah, it's very yeah. So he's implementing automatic reference counting or atomic reference counting. If it's borrowing from Rust, I assume it's the arc, the Rust concept. Yeah. Okay. A, C, B. So in this case, if you join A with B, yeah. And then same thing here. If you join ending with drive and root, you should get blah like this. Okay. Any other thing? Oh, UNC drives. UNC drives. You know, UNC drives in this case is actually not that interesting. We'll just add one test. UNC drive. So instead of C colon, we say slash UNC B C, and this would give us UNC B C. Man, this is gonna be, yeah, Windows is so such a mess. Okay, absolute path starting and ending with drive. C. So this is interesting because we can actually use different ones, but we'll use same one for now. C A and CB, we should get CB with absolute, right, with drive and root. Yeah, there's a combinatorial explosion here. Well, small, very small explosion because our number are small. But like now we have to think about, stop. Now we have to think about, yeah, there's an ordering problem, right? Like you have, you start with a drive and end with a drive and root, and vice versa. And then you can also have starting with no drive but root. Yeah, it's like, yeah. So given any given path, you can either have drive or no drive, root or no root. Yeah. Right? So there are 16 combinations. Oh, 4. Why am I thinking 16? I don't know. Yeah, okay. So we'll try simple joining, starting and ending with drive and root, starting and ending, starting with drive and ending with root. How about that? Starting with a drive, ending with just a root. Okay, so what should we get here? This intuitively should be, yeah, C, B, like that. But let's give it a shot. We start with a drive. Oh, right. Then you can have a path or no path at all. Right. So there's 8. There's eight combinations. That's so interesting. Okay. So B is gonna have a root. So our prediction is C colon and B. Oh, with a root, of course. Okay. And then there's the reverse of that. Simple joining. Maybe I can get rid of simple here. It's nothing simple about this. Anyways, some of them will keep the simple. Okay, so we start with a root, and then we end with this. So what happens here? So in this case, we should get C but no root, right? CB, no root. This guy has a root but no drive. This guy has a drive but no root. Yep. So drive overrides everything. Drive is the root of all roots. Okay. Multiple absolute paths. Multiple paths and root. It's just for this one. So for the following ones, we'll just slightly mix it up a little. So here's C, and then we're throwing. I guess the idea here is D should override, right? So let's switch it up and throw in a UNC. C, UNCC, D. Okay, so in this case, UNCC drive should override everything. So we should again end up with UNC CD. No, UNCC, C, UNCC CD. Okay. Whew. Joining mixed types. This is fine. We'll just keep it as is. Okay, I think that's quite a bit of test coverage for now, for Windows paths. Okay, let's go. Let's push through this. So let's implement that. Let's get our baseline here. How many tests are passing? Or does it even compile? Starting with and ending with. Starting with drive and ending with root. Starting with drive and ending. Nani? Come on, bruh. What the? Oh. Caps lock. What? Panic. Stop. That's spooky. Okay. What happened here? What the? Damn, something really bad happened. No. What? What happened? What? I'm undoing everything, but it's like going way back in history. It's not like I accidentally pressed a bunch of keys. Right? Because this is like the beginning of the POSIX state. We start by replacing the word POSIX, and then we start replacing a couple of words. Replaying everything. So far, so good. But what happened here? And what happened there? No, this is a disaster. What happened? My tests. No. I mean, obviously, I can go back to the video and look at what happened. Like, what is this? What is this change? How? So it looks like this word got appended to a bunch of places. You know, right? Joined. Yeah, so after with, starting. But man, my tests. That's not fair. It just like took me back, set me back by so much. Like I haven't even finished converting the backslashes at this point. Depression, dude. Right. Not even escaped here. And it's been 2 hours, 20 minutes. Okay, here's what I'm gonna do. I'm gonna pretend that. Well, I'm really disappointed, but I think the best thing to do is to go to the implementation. No, I kind of want to test first. Yeah, I only have 8 failures because all the other additional tests haven't been added yet. So let's just do it real quick, okay? Let's just do what we just did real quick. So with absolute drive, we'll do with drive. So C, and here we get C:AB. then with drive and root. Right. Ending with absolute. Okay. Ending with drive. C. Okay. Ending with drive and root. Okay, this is the one we do multiple ones. This is not that bad. We just need to throw in those mixed cases. So this one, let's recover the interesting UNC-C1. Then we'll just get UNCC DE, right? UNCC CD. Okay. So it's the combinatorial ones that's interesting. Oh yeah, I haven't done that one neither. This is where yeah. Okay. This is wrong. Starting and ending with root. Okay. Starting and ending with drive. Just begin with C with same drive. So we have A, B, and then something is wrong here. What is it complaining about? Oh, open paren. Okay. Open brace, I mean. Okay, so CB, this will give us this. Okay. Joining. Starting with drive and ending with root. Okay. Forgot about different drive. Okay, let's mix it up a little bit. Here we get UNC drive. CA. I think that'll work. Yep. Okay. Starting with drive and ending with root. Starting with drive, ending with root. Which one is this again? This will be C. So combine the drive and root, right? Oh, no. Wait, I don't know how I get into this. It has something to do with tmux, I feel like. What was that? That's new. Okay, let's test this in Python. Starting with a drive and end with a root. CA and then \B. Should give me CB, right? C root B, yeah. Okay. C root B, okay. Then the reverse of that, starting with drive. So this one, the drive should completely take over. So got the B. I'm relatively quiet. Yeah, no, it's because I am focusing a little bit more. I'm a little disappointed that I lost some progress. So now yeah, A, B. Okay, I think this more or less is what we had before. I leave even a little bit more. What else am I not testing? Yeah, there's some interesting things like test joining drive only with path, right? This is pretty interesting, I guess. You can have a drive only, and then you have a path. You should get this, right? And then drive only with root. I mean, that's not that interesting. Okay. You just give it a try. Yeah, I started using D colon because that represents my emotion. D colon. Okay. Took me a while to realize this is just tuple syntax with the comma there. Okay. All right. I'm gonna stage everything. Stage all the things. Not loading this again. Everything. Okay. Wait, I said everything. Okay. Wait a minute. What is this? Okay. Now, finally, after how many tests was that? 18 tests. We're gonna pass 18 tests now. Let's go. Joined with paths. Okay. I'm ready. Whew. We have a result string. Feel like I'm in a race. So pumped up. Result. Spell that word in English. Result string is blah, 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 blah. It's gonna be a oh no, we convert everything first. Paths equals self plus paths map as Windows path. So now we have paths return self to squash the error. Okay, for pathing paths, what is the easiest one if path? So is this where I just gave up the efficiency and just say on Windows things is a little slow? Because once I say path.drive, this will trigger a computation that parse out the drive, right? So if path.drive is empty, this means we result Windows pure Windows binary string, aka contiguous array of U16 uint16. Yep. If that's the drive is empty, then result is just taken over by that. So path dot binary string. That's the easiest path. We'll return Windows pure Windows path with result. Okay, so does this make us pass any test? Yeah, we went from what, 18 to 13. Okay, good. What's the project overall? Hi, yeah. So the project is file system library for Swift. So if you couldn't tell, this is Swift. Actually, I don't even know what's my stream title, but yeah, this is Swift, and I'm working on a cross-platform file system library. That's why I was like joining Windows paths. Like I'm implementing the join function today for all the platforms. Yep. Yep. So yep, that's the path. Now what? Let's go. So if the drive is not empty, we just take over and start over, right? But if the next one doesn't have a drive, right? So if we're in the else clause, that means the drive is empty. If result is empty, we wait, really? Is that how that's implemented? Result is empty. Oh, we append it. Oh, yeah. Okay. Right. So let me reset my mindset a little bit. So now we're dealing with a path that doesn't have drive, but it may or may not have a root. And our first path may or may not have a drive, neither, right? So we have a root, but the first path doesn't have a drive. Yeah, this is where things gets a little not easy to hold in your head. So maybe I can have a separate thing for the drive. I'm gonna start. This is a draft, okay? So drive is gonna be a separate variable, Windows string, and then if drive isn't empty, yes, the result will get that, but the drive will also get pass.drive. So I record it separately. Driver. Who said driver? Driver. Oh, I said driver here. Whoops. Okay, so now the drive is empty. So. Other than drive.
Hmm.
You know what? Once we open up the all the stuff, we can play with it because like drive, root, and the rest of the things are actually easier to deal with conceptually. So maybe I should like and also once I start accessing all this stuff, it's like I already paid the performance penalty price or rather. So we have a drive, we have a root, we have a list of segments. Windows binary string. Right, we have all this stuff. We'll just play with them, right? If the drive isn't empty, we'll just take over all three. Drive is pass.drive. Root is pass.root. Segments is pass.segments. This is a reset. Okay. And then if the result is empty, so this is where I was like, why do I do this here as opposed to yeah, I guess that make now this is not that trivial of a condition anymore. I mean, let me just not care about this case at first. Let's see if the path, the drive is empty. Okay, now let's see if the root is not empty. Right? Then we keep the drive and then we replace the root and the segments. That makes sense, right? Yes. Okay. Next. Now we know now this path doesn't have drive or root. So it's just a bunch of segments. Therefore, we just append the segments, right? We just eat it up. And then, then we need to piece everything together. We have the drive, we have the root, we have the segments. We need to connect them. So, we need the drive concatenated directly with the root, I guess. And then we can take the segments and join them, right? Joined separator. Windows. Come on. Constants. Separator byte. So the segments will be joined with the separator byte. And then root exists or not will be attached in front of that. Then drive exists or not will be attached in front of that. And then we have some kind of a error here. Ah. That makes no sense. Hold on. What? Really? It expects argument type. What is the type? Cannot convert value of string. It's a string? No, it's UTF-16, right? Cannot convert value of type string to expected argument type Windows binary string, contiguous array of U16. Joined. Oh, what? Why did I do that? Hold on. I know what's wrong. I don't know why I put it in. Yeah, it should be like this. That's better, right? I don't think this is correct. Cannot convert value of type join sequence. Oh yeah, that's okay. That is okay. All right. So this is result. And then we make a pure Windows path out of the result. Whew. Okay, I'm sure something isn't working, but we got 0 failures. So I guess that's that. Right? I feel like this is greatly simplified by the parsing logic elsewhere. So in the other one, we were basically dealing with whether things are absolute manually, and here we already have drive and root parsed out for us. So that's why it on the surface is like almost as simple as the other one. Obviously, it's less efficient because we're taking each path apart, and then creating a new buffer, joining them together, and then create a new instance from there. Where in the other one, we just piece. I guess the joining part still applies. Okay, that's less bad as I thought. There we go. Do I need to implement anything in paths? I feel like that's already taken care of because all it does is forwarding, right? Okay. So that's taken care of. I guess I can delete all this because I plan to use the protocol to cover the documentation. So this just confuses things and makes me having to update multiple places. So let's just take this opportunity and delete it. And I also feel like I did a bunch of things here, but I'm just too lazy to divide it up into different patches. Just run make update CMake list, update test manifest. That should update add some changes, right? CMake gets these 2 new tests, and then obviously each individual test gets updated into the manifest for Windows and Linux. Okay. Yeah, I propose to not call it in SwiftPM, not call it Swift test generate Linux main anymore because I'm using Linux main in Windows as well. Okay, so let's push this up to our branch. This is implementing path joining. Okay, and wait, there's more. What is this? Oh, nice. Me like. So when I commit, Swift format gets wrong, and then it finds this little sugar for us. Nice. I need to make a habit of running it manually because it's a little surprising, you know, after you commit, you find some new changes. Let me push this up, and then we can finally get to play with Windows. So let's go back to my streaming machine, which is the Windows machine. We run some dank shells here. Source, D1, pathos. We can fetch the origin, I guess. And then we can reset. We'll make sure I'm on the right branch. Reset hard, origin, next. And then I can, you know, kind of delete this a little bit. One nice thing about using SSH here is I get to use tmux shortcuts. Like just now, I jump back and copy a piece of string. That's like not possible on Windows. So okay, now what? Now I do the shell thing. So script. There's some extra scripts in here. Run this. Run that. Make test. And behold. Oh, not make the build test. XE test on Windows, ladies and gentlemen. Yeah, and sometimes this happens, but that's fine. It's like some temporary data gets messed up. I've learned to not care and simply move on. Hello? Did I not copy that? I was just praising the convenience. No way, this doesn't exist. Okay. Yeah, there's some like impure like caching thing going on, which is really annoying. But I don't know why I couldn't delete it. Oh. Okay, now script build a test. Maybe script make again. Build. I feel like that built too quickly. It does have the changes here. So it's only when it runs tests it got into some trouble. Maybe I didn't delete the right one. All right, good evening, Gilad. Come on, dude. All right. remove all of this. What? I'm confused. This is supposed to... What? I've never had this much trouble with this before. Do I just not know how to delete this? I feel like this is the right syntax. I say yes. And then if I take a look at this, it's still there. So that's not good, right? So is it like del dash R? I don't know. Okay, let's use PowerShell. PowerShell is a little bit more reasonable. Can use remove, right? Yes to all. Okay. Okay, this is good. Finally. I just don't know. I didn't know how to... 30 tests. That's not right. Something didn't build correctly, I feel like. Or is it because... No, this has pass joining. I have Vim on Windows as well. We can take a look. Tests, Linux manifest. Okay, that's not super interesting. I guess it's in Pathos tests. It's like axi something something, right? Join. Yeah, the joining tests are here. Yeah, this is really wonky with Windows and SSH, but they're there. Why did it only run 30 tests? And it says no work to do. Oh, let me delete. Let's delete this file. I'm just gonna do a different one. PowerShell, source, Dawn, Pathos. Okay. Apparently that's the way to delete files. I have no idea how to do it in the old shell. Oh, now I need to make again. Okay, looks like it actually did some work there. I think I don't expect things to fail. It's just good to know, right? Also, I think the stream is coming up to 3 hours. I probably should stop the stream. Okay, 57 tests all passed, and it definitely includes the joining test we wrote today.
which is pretty good, pretty good. Just one last thing. I'm gonna go to the GitHub project and look at the status of CI. Okay, CI also passed. Okay, that's really good. All right, cool. Guess that's it. I was going to also implement a custom operator for this, but we'll do that. I'll probably do that right now, but off stream. Or should I? Yeah, I'll do it off stream. Okay. Thanks for watching. If you are watching not on Twitch, please consider watch me on Twitch in the future. And if you're watching it on YouTube, I started to make more YouTube videos recently. And I have a new video in the works. So make sure you subscribe there. Yeah. Have a good evening.